Timber, America's most abundant and only renewable natural resource. Burke Parsons Bowlby Corporation is a major producer of timber products. Railroads depend on us for superior quality products from the best slow-growth oak area in the world, the Appalachians. Our 4 plants are located in Spencer, West Virginia, Goshen, Virginia, DuBois, Pennsylvania, and Stanton, Kentucky, in the heart of this hardwood region. We contract with local sawmills to provide us with the dense oak and other hardwoods we need. This timber is in great demand worldwide. In the forest of the Appalachian Mountains, the lumberjack identifies a suitable tree. This one is a prime candidate for BPB. After several trees have been cut, they're skidded to a landing. The rubber-tired skidder operator sorts logs at the landing. This will make loading the truck easier. The truck driver arrives at the landing and loads the truck using the hydraulic boom. The log truck arrives at the sawmill. Its first stop is the scales. After his load is weighed, the driver unloads, sorting as he goes, separating small diameter blocking logs from the larger tie cuts. Sawmills receive 5 small logs for every large timber log, 3 times the cost per log. Prior to milling, all logs are graded, inspected for knots, heart rot, shake, bark pockets, and any other defects that would weaken a heavy timber. Sawmill operators will be able to make standard lumber from logs not suitable for BPB. After this is done, the logs move to the mill. The first step of the sawmill operation is the debarker. Bark is removed to provide clean logs for the head saw. All the bark that is removed is made into mulch. The clean logs will make the saws last longer while reducing dirt inside the mill. The clean logs move down a line into the mill through a chain trough and onto a log deck where they feed the carriage for the head saw. The head saw cuts these logs into square timbers. The sawmill operators work very closely with the BPB procurement department so they know exactly what dimensions the timbers need to be. We get our specifications from our customers, you tell us what you need, and we'll contract with a sawmill to get it for you. Timbers that don't meet our specific needs are then fed into the bull edger for lumber. BPB timbers are then rolled out stacked and banded ready for shipment to our plant where they'll be trimmed and treated. When the producer arrives at the plant, his truckload of square timbers is unloaded. Then it's marked as being from that producer and stored in our yard ready for the trimmer. Every timber that goes through a BPB plant must pass our high quality control standards. The first QC inspection is here at the beginning of what we call our green chain. The ties are loaded onto a deck where our grader visually checks them to customer and industry standards. As he does this, he also tallies each producer's total and readies the timbers for the first trim saw. This saw trims a chainsaw cut off both ends and will cut the tie to the length specified by the customer. Due to the amount of high-speed machinery, we have taken special precautions for our employees' safety here at BPB. Fabricated shields such as this one help protect our workers from accidents. After a tie passes through our trim saw, if the customer requires, it's branded. Here, a Conrail brand is applied. The ties are running through an incisor. This perforates the outer part of the timber, allowing it to absorb more treatment and reduce splitting during seasoning. These ties are then stacked, awaiting pressure treatment. Prefabrication is one area where BPB really excels. Our crossing panels, bridge ties, and all our other products reflect our dedication to quality. Here at the planer, where timbers are cut to size, our planer operator closely scrutinizes every timber, rejecting any that do not meet our standards. Good timbers are fed into the planer. When they come out, they're fed into a bay where they are measured and checked before being fed into the flangeway machine. BPB has developed a foolproof method for constructing panels. The timbers are laminated together by driving a 3/4 inch dowel through an undersized hole. This dowel will bind with the wood, making it virtually impossible to separate the timbers. At the same time, the panels are being drilled for spikes. The laminated drilled panel is fed to the DAP saw, where a lineal DAP is cut to make way for the rail flange and the tie plates. After the DAP is cut, the panel is kicked off to the double-end trim saw. This saw is set up according to what the customer specified as desired length. Here, it is 8 feet, 1 1/2 inches, and it trims both ends at the same time, ensuring a square cut and uniform length. After trimming, the panel falls on a deck, cleaning the shavings from the holes. Here, another quality control measurement is taken. Height, width, length, and DAP are all measured. These finished panels are stacked into a bundle, ready for pressure treatment. BPB Corporation has been in the pressure treating business for over 30 years. In protecting wood products from insects and decay, we are the experts. Depending upon the degree and materials of treatment, timbers will spend anywhere up to 24 hours inside our cylinders. Like a giant pressure cooker, the cylinders heat and pressurize, forcing treatment into the timbers inside. We can treat green logs by boiling the water out under a vacuum, enabling the pressure treatment to fill the void left by the water. We take special precautions while unloading a charge from the cylinders. Our operator must wear a respirator to protect him from the vapors. Once the cylinder door is open, the bridge can be placed in and the charge of pressure-treated material can be removed. It is now ready for one last quality control inspection prior to shipping. Our QC inspector bores into the pressure-treated material and pulls out a sample that he will test in our lab. Then a plug is driven into the hole. Then he makes a visual check of all the timbers. Defective ones are marked with spray paint. These timbers will be rejected and sold for other purposes. In the lab, our boring samples are tested for retention of the pressure treatment. Having passed all of our quality control standards, these timbers are ready to be shipped. BPB timber crossings are built to last. No matter how well we built them, they're still only as good as their installation. If one of our crossings is installed correctly, it will last many years. Conrail has developed a very successful method of installation. This old crossing is due for replacement. Years of highway and rail traffic, plus a number of other factors, contribute to the deterioration of any crossing. Since this crossing was installed, new methods have been developed to help preserve them. These methods will be used by Conrail to replace the old crossing. The new BPB crossing has been delivered, plus trap rock, drainage stone, and so on. A 78-foot track panel is prefabricated by the crew at the job site. This panel will use a slightly heavier rail than the main track, plus double shoulder tie plates. Any joints are welded. The ends of the rail are bored for connection with the compromise bar. This panel will be lifted onto the rail and slid in to replace the section where the crossing is now. All highway traffic has been detoured and the road is closed. On the roadway, a cut is made about 10 feet from the track on each side. This cut, when abrasive saw, will make a clean break in the pavement. Then this area is excavated to prepare for the removal of the old track, which will be removed in 3 sections. This crossing has an asphalt center that's being removed. BPB crossings are 100% oak hardwood. All this has been done with the track in service. Now that the excavation is done, the track must be cleared. This is the last train that will run over this old crossing. Rail traffic takes a heavy toll on the wooden cross ties beneath it. The continuous pumping of the rails under the train's weight is seen here. After the train is gone, the track is taken out of service. In order to cut the rail, ties are removed from under it at each place marked for a cut. The backhoe makes this look easy. An acetylene torch is used to cut the bolts on any joint bars in this section. The other points in the rail are cut with a torch as well. Once the section to be replaced has been cut into 3 separate panels, it's ready to be removed. A chain is attached to each end section and they're pulled out. The center section, which still has the old crossing timbers attached to it, is flipped out with the end loader. These old sections will be dismantled away from the work area. This method will help get the track back in service quicker. The ends of the rails are cut to precise measurements with a rail saw. About 10 to 15 inches of dirt and old ballast is removed from the track bed. Unless a big moisture problem is discovered, this area is excavated only to the original hard pan of dirt and rock. After the track bed is cleared out, ditches are dug for drainage on each side of the track and connected by a 3rd ditch on the lower end to carry off the drainage. Next, the track bed is carpeted with 2 100-foot geotextile filter fabric sections. This material is made to conform to the ditches and is designed to keep the ballast from becoming contaminated with dirt while allowing water to drain. After the carpet is laid, a 6-inch galvanized steel perforated corrugated drain pipe is laid down into the ditch on top of it. Some of the connections were made prior to installation. The remaining connections will be made in the ditch. Stone is poured in, around, and under the pipe. Just a little is used at first to hold the pipes up while the Conrail crew works to set the pitch for optimum drainage by using a transit. Once this is done, the pipes are secured into position with more stone. With the drainage set, next the trap rock can be poured in over it. 6 to 10 inches of trap rock goes in to make a base for the track panel. At the same time, the ties removed at the rail cut points are being replaced. The track bed is leveled, again using a transit. The trap rock is in place, the track bed is leveled, now it's ready for the installation of the prefabricated track panel. Using an end loader to pull it and a backhoe to guide it, the panel is pulled into position. Old rails and ties were used to skid the panel over the new track bed. These prevent the cross ties from digging in. The panel is jacked up to remove them. The rails are lined up with each other. Compromise bars are used to connect the new, larger 132-pound rail to the mainline 130-pound rail. The signalman drills the new rail and installs the signal connectors. Ballast is poured in between the ties. The cribs are filled with rock, ready for the tamper. The new rail is spiked into the new ties at the joints. The new track is tamped and aligned mechanically. Once it has been tamped, it is put back into service. After train traffic, it will be tamped again before the crossing is installed. This track was out of service about 10 hours. Prior to installing the crossing panels, the track is swept clean. Rocks are pushed from on top of the ties and the rail anchors are removed so the panels will fit solidly on the ties. The track is measured by the engineer who marks the center. At the same time, the knuckle boom unloader operator loads the crossing panels on his log truck. He carefully arranges them so they'll come off in order. The engineer marks where the roadway ends on the side of the rail. The actual installation begins with an end outside or field panel. It's lowered into place with the knuckle boom unloader and positioned against the rail. Much care is taken to align this panel in its correct position because all the others will depend on it for their positioning as well. The rest of the field panels on this side of the track are put into place with the knuckle boom unloader. Then the cross ties are drilled using the pre-drilled panel holes as a guide for 14-inch steel washer head drive spikes. Shavings are cleaned from the holes. The spikes are started by hand. Then they're driven in with an air hammer that has a socket on it that just fits on the head of the spike. As the hammer drives the spike, it twists into the hole. This twisting motion will reduce wood fiber damage, helping to maintain the strength of the timber, and also will make the spike hold better. These panels are spiked into every tie. They're held into position until the first spike is driven. Periodic checks are made to ensure proper alignment throughout the installation process. While the crew is busy drilling and spiking the field row, the gauge or center panels are being lowered into position in the gauge of the track. These panels are drilled and spiked in the same manner. Filler blocks are placed in the flange area between the panels and the rail. These blocks protect the ballast from contamination by highway dirt and so on. They can be attached with spikes if desired, but here they are free to move. The same process is repeated for the rest of the gauge panels. With the gauge panels all in place, the log truck moves to the other field road. Using the marks on the track for a reference, the first panel is laid down, and the last field row goes down exactly the same as the other panels. The finished crossing is now ready for the asphalt paving contractor. These timbers will provide many years of service because where cost and service life are important, wood excels. For an excellent crossing surface that is durable as well as economical, Burke Parsons Bowlby wood crossings are the best.